5 minutes ago, James Webb captured an image that stunned researchers because nobody expected these strange details to appear. Instead of matching predictions, fresh evidence raised new questions that experts still cannot answer. Before we uncover every clue, tell me your country below because I'm curious how far this discovery travels today. Ready? Good, because what you're about to see becomes even stranger after scientists check the raw data twice. Nothing about this observation behaves the way anyone predicted. Stay with me until the end, because every new reveal makes that first unbelievable picture far more shocking than it first appeared. The first thing scientists noticed wasn't something bright or dramatic. It was something that simply shouldn't have been there. When James Webb finished sending the newest image back to Earth, researchers expected another beautiful view of deep space. Instead, hidden inside the data was a feature that refused to match the models they had trusted for years. At first, many believed it had to be an error. Telescopes can produce strange artifacts. Software can misread faint light. Even tiny mistakes during processing can create shapes that never really existed. That seemed like the safest answer. But the team didn't stop there. They checked the raw files again. Then they checked them a second time using different methods. The mysterious detail remained exactly where it had first appeared. Nothing changed. Every fresh review pointed toward the same conclusion. The image itself was real. That's when excitement quietly replaced confidence. Instead of celebrating immediately, scientists became cautious. Extraordinary discoveries demand extraordinary proof. Nobody wanted to announce something that could later be explained away by a simple technical problem. So the investigation became even more careful. Independent experts compared measurements, reviewed exposure times, and examined every possible source of interference. They searched for anything that could explain away the strange result. Nothing did. Here's the part almost nobody is talking about. James Webb isn't simply taking better pictures than older telescopes. It sees the universe differently. Its powerful infrared instruments detect light that has traveled across space for unimaginable lengths of time. Some of those signals began their journey billions of years before Earth even existed. That means every unexpected detail inside a Webb image has the potential to challenge ideas that scientists have spent decades building. Stop for a second and think about that. One unexpected feature inside a single photograph could force researchers to revisit years of published work. That's why nobody rushed to make bold claims. Careful science moves slowly, especially when the evidence refuses to fit. Then another surprise appeared. As more specialists studied the image, they realized the strange feature wasn't standing alone. Smaller clues surrounded it, each pointing toward the same unexpected direction. Alone, none seemed remarkable. Together, they painted a picture that became harder to ignore. Scientists had prepared for a routine observation. Instead, they found themselves asking entirely new questions. If their interpretation was correct, this wasn't just another impressive James Webb image. It could become one of those rare observations remembered for changing how future discoveries are understood. Yet one enormous problem remained. Nobody could explain exactly why the telescope had captured this astonishing scene in the first place. And that unanswered question would lead researchers down an even stranger path than anyone imagined, because the next layer of evidence didn't simply challenge expectations. It threatened to overturn them completely. That unanswered question spread far beyond the team that first examined the image. Within hours, researchers from different observatories and universities began looking at the same data, hoping to find a simple explanation everyone had missed. Instead, every fresh review made the mystery even harder to dismiss. The evidence kept pointing toward the same unexpected conclusion, and that was exactly what made scientists so uncomfortable. This wasn't the reaction anyone expected. Normally, a new space image creates excitement for a few days before attention moves somewhere else. This time felt different. Experts weren't just sharing a beautiful picture. They were debating whether the image revealed something that current theories could not fully explain. Every measurement raised another question instead of providing an answer. If you're enjoying uncovering the real story behind headlines like this, hit subscribe now, because the biggest discovery is still waiting ahead. Now here's where everything became even stranger. Scientists compared the latest Webb observation with older images taken by other telescopes. At first glance, they seemed similar, but James Webb was seeing details that previous instruments simply couldn't detect. Features that once looked ordinary suddenly appeared far more complex. Tiny patterns hidden inside the faint light suggested that something unexpected had been there all along, waiting for technology powerful enough to uncover it. That changed the entire conversation. Instead of asking whether the telescope had made a mistake, researchers began asking whether their understanding of this region of space had been incomplete from the beginning. That's a much bigger question. It doesn't challenge one photograph. It challenges years of scientific assumptions built from older observations. Pause for a second and think about what that really means. Imagine reading the same book your whole life, then finding an entire chapter that somehow nobody noticed before. The story hasn't changed, your understanding of it has. That's exactly how many scientists describe this moment. James Webb wasn't creating a new universe. It was revealing one that had always been there, hidden behind limits older telescopes could never overcome. Still, not everyone agreed. Some researchers argued there might be another explanation. Perhaps unusual dust affected the light. Maybe an unexpected viewing angle created an illusion. Others suggested that unknown physical conditions could be changing what Webb detected. Every possibility had to be tested before anyone could claim a genuine breakthrough. That's how real science works. Extraordinary discoveries aren't accepted because they sound exciting. They survive because every alternative explanation eventually fails. Right now, that process is still unfolding. Teams across the world continue examining every pixel, every measurement, and every tiny detail inside this remarkable image. Yet one discovery kept refusing to disappear. No matter how many times the data was reviewed, one specific feature remained impossible to ignore. And once scientists calculated what it might actually mean, the conversation shifted from surprise to genuine disbelief. Because if those numbers were correct, the next revelation wouldn't simply rewrite one chapter of astronomy. It could force scientists to rethink an entire piece of the universe. The breakthrough wasn't hidden in the image itself. It appeared when researchers started measuring what the telescope had actually captured. That's when the numbers stopped making sense. According to long-standing models, this region of space should have looked very different. Instead, James Webb revealed structures that appeared larger, brighter, and far more developed than anyone expected to find. For a moment, nobody knew what to say. The discovery wasn't impossible. It was simply arriving far sooner than current theories predicted. If those calculations were correct, then some of the earliest objects in the universe had somehow formed much faster than scientists believed they could. That wasn't a small adjustment. It challenged one of the biggest assumptions about how the early universe evolved after the Big Bang. Here's the detail that changes everything. James Webb can detect ancient infrared light that has traveled across the universe for billions of years. Every faint signal acts like a message from the distant past. The farther Webb looks, the farther back in time it sees. That means the single observation wasn't showing scientists what the universe looks like today. It was showing them what it looked like when it was still incredibly young. That's what made everyone stop. Researchers expected to find young galaxies slowly growing into larger ones. Instead, several appeared surprisingly mature, almost as though they had skipped important stages of development. Some contained far more stars than expected. Others looked unusually organized for their estimated age. None of those details fit neatly inside existing computer models. And that's where the debate exploded. One group argued that the models must be incomplete. Another believed hidden factors, like dark matter or unknown physical processes, could explain the strange observations without rewriting everything. Others urged patience, reminding everyone that one remarkable image cannot overturn decades of research on its own. They're right. Science doesn't move because of excitement. It moves because evidence survives every attempt to prove it wrong. That's exactly what researchers are doing right now. Every calculation is being checked. Every observation is being compared. Every possible mistake is being hunted down before anyone accepts such an extraordinary conclusion. But something refuses to go away. No matter which explanation scientists tested, the same uncomfortable question remained. Why did the universe seem capable of building massive, complex structures so much earlier than anyone thought possible? That single question has now become one of the biggest conversations surrounding James Webb's discoveries. Stop and think about that for a second. One image has already sparked debates inside research teams around the world. Papers are being reviewed. New observations are being planned. Competing ideas are racing against one another. Everyone wants the same answer, yet nobody can honestly claim they have it. And just when scientists thought they had identified the biggest mystery, another clue hidden inside the same observation suggested the story was about to become even stranger than anyone had imagined. It wasn't a single bright object that caught their attention this time. It was the way several distant structures appeared to share the same unexpected behavior. At first, that sounded impossible. One unusual galaxy might be explained by chance. Two could still be coincidence, but finding the same pattern again and again forced researchers to ask whether they were looking at something much bigger. That's when the discussion changed completely. Instead of focusing on one remarkable image, scientists began wondering if James Webb was revealing a problem hidden across the early universe itself. If that turned out to be true, then the discovery would no longer be about one surprising observation. It would become evidence that some of astronomy's most trusted ideas might need another look. Here's the part almost nobody is talking about. Every scientific model is built using the best evidence available at the time. When better evidence appears, those models must change. That doesn't mean previous scientists were wrong. It means technology has finally become powerful enough to uncover details that were invisible before. James Webb is doing exactly that, opening windows that no telescope has ever opened before. But another question quickly appeared. If these ancient galaxies really formed so early, where did all the material come from? Building billions of stars takes time. According to current models, there simply shouldn't have been enough time for some of these massive systems to exist when Webb appears to be seeing them. Scientists offered several possible answers. Maybe early galaxies formed much faster than anyone expected. Maybe hidden clouds of dark matter helped them grow more quickly. Some researchers even wondered whether unknown physical processes were shaping the young universe in ways nobody had considered before. Every explanation sounded exciting, but none solved every piece of the puzzle. That's why the debate is still wide open. Researchers around the world are now using computer simulations, fresh observations, and independent calculations to test every possibility. One prediction after another is being compared against James Webb's latest data. Some ideas survive, others fail almost immediately. Each new result removes one path while opening another. Stop and think about that for a second. The biggest telescope ever built isn't simply answering old questions. It's creating entirely new ones. Every fresh image seems to reveal another mystery hiding behind the last one. Instead of making the universe feel simpler, James Webb is showing that reality may be even more complex than scientists imagined. Yet one final detail refused to fit inside any existing explanation. Buried within the newest measurements was a feature that didn't just challenge ideas about galaxy formation. If confirmed, it could also change what researchers believe happened during the universe's earliest moments. And that possibility has now become one of the most closely watched investigations in modern astronomy, because the next round of observations could either support this astonishing discovery or force everyone back to the drawing board. To understand why this matters so much, you first need to understand what makes James Webb different from every space telescope that came before it. Webb doesn't simply take sharper pictures. It captures light that has been stretched across the universe for billions of years. As space expands, ancient light changes from visible colors into infrared wavelengths. Human eyes can't see that light, but James Webb was built specifically to detect it. That's its greatest strength. Its massive golden mirror collects faint signals that older observatories could barely detect. Those tiny pieces of light are then studied by incredibly sensitive instruments that separate them into detailed patterns. Those patterns tell scientists what distant objects are made of, how hot they are, how fast they're moving, and even how old they might be. That's like solving a mystery without ever visiting the scene. Imagine standing thousands of miles away from a city at night. You can't hear anything. You can't speak to anyone. Yet by studying the lights alone, you begin figuring out what buildings exist, where people gather, and which streets remain busy. James Webb works in a similar way, except its clues come from places so distant that the light began traveling long before our planet looked anything like it does today. Here's where things became even more fascinating. When researchers compared this latest image with Webb's earlier observations, they noticed a familiar pattern. The telescope that wasn't producing random surprises. Similar discoveries had appeared before, each quietly hinting that something about the early universe might be more complicated than expected. Alone, each observation raised eyebrows. Together, they started forming a much larger picture that made scientists pay even closer attention. Instead of treating each discovery as an isolated event, teams began connecting them together. New computer models were created. Older theories were tested again. Fresh observing schedules were approved to gather even more evidence. Every new image became another piece of an enormous puzzle that nobody had fully solved. Pause for a second and think about that. The universe hasn't changed overnight. Our ability to see it has. Every improvement in technology gives humanity another chance to discover something previous generations simply couldn't observe. That's exactly what James Webb is doing. It isn't rewriting history, it's revealing chapters that have always existed but remained hidden until now. Even so, one challenge continues to slow everything down. Scientists cannot rely on a single observation, no matter how remarkable it appears. Every surprising result must be confirmed through repeated measurements, independent studies, and future observations. That's why researchers remain careful with every announcement. They know today's exciting possibility must survive tomorrow's evidence. Yet while those tests continue, another mystery has already started attracting attention. Because hidden beyond this astonishing image lies a question even bigger than the discovery itself, one that could reshape how humanity understands the birth of the entire cosmos. For decades, scientists have believed they understood the basic timeline of the early universe. After the Big Bang, matter slowly gathered together under gravity. Small clouds became the first stars. Those stars joined to form young galaxies. Over billions of years, those galaxies grew larger through countless collisions and mergers. It was a simple story supported by years of observations. James Webb may have complicated that story. The newest image suggests that at least some parts of the universe matured much faster than expected. Instead of finding small, faint systems struggling to grow, researchers are seeing objects that already look surprisingly large and well organized. It's almost as if parts of the universe skipped several important steps. That's an incredible possibility. If these observations continue to hold up, scientists won't simply update one chart inside a textbook. Entire computer models that explain how galaxies formed may need to be rewritten. New simulations will have to account for structures appearing earlier than anyone thought possible. That could change how researchers study everything from dark matter to the birth of the first stars. But there's another side to this story. Many astronomers remain cautious, and for good reason. Science becomes stronger by challenging exciting ideas, not by accepting them too quickly. Some researchers believe hidden effects inside the data could still explain what James Webb is seeing. Others think current models may only need small adjustments rather than a complete overhaul. Nobody knows the answer yet. That's exactly why this discovery has captured so much attention around the world. Every research team is approaching the same mystery from a different direction. Some are building new computer simulations. Others are collecting fresh observations. Several groups are comparing James Webb's measurements with information gathered by ground-based observatories, hoping another piece of evidence will finally point toward the correct explanation. Here's the detail that makes this moment so exciting. We are watching science happen in real time. Instead of reading about discoveries years after the debate has ended, we're seeing experts ask difficult questions while the evidence is still arriving. Every new observation has the power to strengthen one idea, weaken another, or introduce an entirely unexpected explanation that nobody has even considered yet. Stop and imagine living through that. Future generations may open astronomy books and read about this period as the moment researchers realized the universe was more complicated than anyone had imagined. Or they may discover that today's mystery had a surprisingly simple answer all along. Right now, nobody can honestly say which outcome is waiting. One thing is certain. James Webb has already changed the conversation. The telescope isn't just taking breathtaking images. It's forcing scientists to ask better questions than ever before. And while those questions continue to grow, another round of observations is already being prepared. Those new images may finally reveal whether this astonishing discovery marks the beginning of a scientific revolution or simply the first clue in an even greater mystery that nobody saw coming. Right now, scientists aren't waiting for years to find the answer. The investigation is already moving forward. Research teams across the world are scheduling new James Webb observations, comparing fresh measurements, and testing every possible explanation. Every hour brings another chance to discover whether this remarkable image truly changes our understanding of the universe or whether another hidden factor is still waiting to be uncovered. That's what makes this moment so unusual. Most scientific discoveries take years before they capture public attention. This one is unfolding while the entire world is watching. Every new data set is examined almost immediately. Every research paper is reviewed by experts looking for mistakes, missing details, or stronger evidence. Nobody wants to rush toward an extraordinary conclusion without proving every step along the way. Here's where the pressure begins. If future observations match what James Webb has already seen, confidence in this discovery will grow rapidly. Scientists will have far stronger evidence that current models need serious updates. But if new images produce different results, researchers may have to rethink everything once again. Either outcome teaches us something valuable about how the universe works. That's the beauty of science. Real discoveries aren't decided by opinions. They're decided by evidence. Every new observation either strengthens an idea or weakens it. The universe doesn't care what scientists hope to find. It only reveals what has always been true, one observation at a time. Pause and think about that. Somewhere, at this very moment, James Webb is quietly collecting more ancient light that has traveled across space for billions of years. Those faint signals are carrying information from a time when the first galaxies were beginning to appear, long before Earth existed, long before our sun was born, long before anyone could imagine building a telescope capable of seeing so far into the past. And the next images could be even more surprising. Researchers are especially interested in finding out whether similar structures appear in completely different regions of the sky. If they do, this won't look like an isolated mystery anymore. It will suggest that the early universe behaved in ways scientists have underestimated for decades. That possibility alone explains why astronomers are paying such close attention to every new observation James Webb sends home. Yet one question still refuses to disappear. If the universe really evolved faster than expected, what caused it? Was dark matter more influential than scientists believed? Did the first stars form under conditions nobody has fully understood? Or is there another piece of physics still hidden beyond our current knowledge? At the moment, nobody has a complete answer. What we do know is this: every remarkable discovery begins with a single observation that refuses to fit. James Webb has already delivered that observation. Now the scientific community is racing to determine whether this image will become another fascinating mystery or one of the greatest turning points in modern astronomy. And the answer may arrive much sooner than anyone expected. When this investigation finally reaches its conclusion, The result will almost certainly fall into one of two paths. Either future observations will confirm that James Webb has uncovered something truly extraordinary, or they'll reveal a hidden explanation that nobody has recognized yet. Both outcomes would become major victories for science, because every mystery solved brings us one step closer to understanding the universe we call home. That's easy to forget. People often imagine science as a collection of finished answers printed inside textbooks. The truth is very different. Science is a process of asking better questions every time new evidence appears. James Webb isn't replacing everything scientists already know. It's testing those ideas in ways that were impossible only a few years ago. That's why this image matters so much. It isn't valuable simply because it looks beautiful. It matters because it forced experts to stop, question their assumptions, and examine the evidence again. That willingness to challenge old ideas is exactly what has driven every major scientific breakthrough throughout history. Every great discovery began with someone looking at familiar data and realizing something didn't quite fit. This story is no different. One unexpected image led to careful reviews. Those reviews uncovered surprising measurements. The measurements raised difficult questions. Those questions inspired new research around the world. Now, every new observation James Webb sends back has the potential to either strengthen this remarkable discovery or point scientists toward an entirely different explanation. And that is where we stand today. Some of the brightest minds on Earth are studying the same tiny details, comparing results, building better models, and searching for answers that may change astronomy for decades to come. Nobody is claiming the mystery has been solved. In many ways, the investigation has only just begun. Stop and think about the bigger picture. Every time humanity builds a more powerful telescope, the universe surprises us. Galileo transformed our view of the solar system. Hubble revealed galaxies beyond our own. James Webb is now opening another chapter, showing us places and moments that no human being has ever witnessed before. Each discovery reminds us that the universe is always larger, stranger, and more fascinating than our imagination. Maybe that's the greatest lesson of all. The biggest discoveries rarely happen because scientists find exactly what they expected. They happen because reality refuses to follow the rules people thought were already settled. That single image, captured only minutes before the world began talking about it, may become another example of that timeless pattern. Whether this observation eventually rewrites our understanding of the early universe or simply leads to an even better explanation, one fact is already beyond debate. James Webb has once again reminded humanity that the greatest mysteries are not hiding in science fiction. They're waiting in the real universe, patiently revealing themselves one astonishing image at a time. And somewhere beyond the darkness, the telescope is already capturing the next discovery before the rest of us even know the question to ask. And while scientists keep searching for answers, James Webb continues looking deeper into the universe than ever before. The next image could confirm everything you've seen today, or change the story again. Subscribe now so you don't miss the next